Good afternoon, class. My name is Glenn Chamberlain, and this is the database presentation for Professor Green's ISA 4220 course for fall of 2017. Database is not something I was very familiar with at all before starting this assignment. Up until now, all the protocols we've been dealing with, I've used in day-to-day operations in my career, so this was new and exciting for me. Hopefully, we all learned something during this presentation. And if it sounds a little different than my other presentations, it's because my office just got new hardwood floors and it's made a big echo in my office. So here we go. So we're going to go over PostgreSQL. I'm not real sure how to pronounce that yet. And we're going to do an in-depth technical discussion on how it works. And we're also going to go over how to harden it. So PostgreSQL, also known as Postgres, is an object relational database management system, which implements SQL or SQL querying languages. SQL stands for Structured Query Language, and it's a programming language used to manage data stored in relations, which are more commonly known as tables. A relational database management system, or RDMS for short, provides a structured system for storing, organizing, and accessing data within databases. Postgres is an advanced open source database available everywhere and to anyone free of charge, so it's open source. It's a popular RDMS that can be used to handle the data of websites and other applications. A Postgres server manages one or more instances of a database, which is simply a collection of SQL database objects with an appropriate label, so it labels them all together within one database. When a connection of the Postgres database server is being attempted, the client must specify the name of the database it intends on connecting to, and only one database is allowed to be selected per connection. But an application is not restricted to how many connections it may open or which database it may request a connection to. Databases can be organized into schemas, which are logical structures managed by granting privileges over the database objects. Databases can be created with simple commands create database and deleted with the drop database command. The Postgres Global Development Group describes SQL object hierarchy as being in the following order. So it goes server, database, schema, table. Postgres uses a client-server model with a given session consisting of two interacting processes. The first process is the server, which manages the database and accepts connections from client applications. A user's client application is the second process involved in the interaction, and it's the party attempting to perform a database operation. If the connection being made is remote, the client and server communicate over a TCP/IP network, as everything over a network does, basically. A client application specifies which Postgres database user it means to log in under when it establishes a connection. Client authentication is controlled by the configuration file located here. It's the pg_hpa.conf, in which the HPA actually stands for host-based authentication, so it's easy to locate in that manner, or easy to remember what that file does. A given record within this file specifies the connection type, the database accessible to a user, the username, and the IP address if configured that way, along with the authentication type selected and the authentication option that's allowed. An example entry that can be found within the pg_hpa.conf file for an allowed connection is shown here. An authentication method, which is an example of ident there, specifies the authentication method to use when a connection matches a record. So if those previous options are matched, so the database, the user, the address, the method ident authenticates. There are many different authentication methods that Postgres can support. Some examples like MD5, Kerberos, GSS API, Radius, SSL. These probably look familiar because a lot of the protocols we've used support these same things. They're pretty universal. The trust authentication method is one of the more simple options that can be selected and only requires that a client has Postgres credentials to gain access. In the previous example that we put up on the slide where we went over the IP address of the user, and when ident authentication method is chosen, Postgres acquires the client's operating system username from an ident server and uses it as the database username. So when you log on to the computer with your username and password, it's going to use those credentials to access the database. When a client needs to log in as a different database username than what was used to authenticate with, a username map can be applied to map the operating system username to an alternate database user. So that way, if you don't want those same credentials that you log onto the computer with to be used, there's behind the scenes configuration that takes place to, it literally maps one username to another, and that's what it uses to authenticate. This is what is referred to as authentication option, and options can be appended to any record found in that same configuration file, so that pg_hpa.conf file, which use an external authentication method. Database access permissions within Postgres are managed by roles. A role is an entity, and depending on how it is set up, can function as a user or a group of users. A role can own a database object and may assign privileges for that object to other roles in an effort to control who or what may access an object. Within Postgres, a new role can be created using the create role command. Using the same syntax, role can also be dropped by replacing create with drop. A freshly created Postgres database system always contains at least one role, and this role is a super user role. By convention, the super user role is named Postgres. No other role can be created without first connecting to this role. Kind of like within the Linux environment, the super user is used to create and edit, modify the system. The same Postgres role is used to do so. So you need to link to that one in order to do anything else initially. Every connection made to a Postgres server is made using the name of a role, which dictates initial privileges of a given connection. A role with the login attribute is what can be considered a database user. Excuse me. There are two options for creating a role with login abilities within Postgres. You get create role, and it'll be the role name, login, and then create user with the role name. There are also programs create user and drop user, which can be called from the shell command line to create or drop a role with the login attribute. So that's kind of how the PostgreSQL database system works, and there's much more to that. People get paid big bucks to manage databases. It's a whole major. If you're interested in it, great. I suggest go learning more about it. We're going to continue to learn more about it without harden it here, but it's a very specific niche, and I know a lot of people that do enjoy database management. I'm not one of them, but that being said, here's some steps you could take to harden your PostgreSQL server. So you can control connections with that same configuration file that we discussed. Within that file, no connection should have trust as selected authentication method. Any connection should be given proper authentication in order to make a connection. So limit connections to known IP addresses is a good practice. It can be done by specifying an IP address or range of IP addresses that are allowed to make a connection as shown here. It's like same thing we were talking about before, where the address is where it's coming from and has to utilize that given method for that specific user to access the specific database. Obviously, all databases with all users, probably not the best case, but given the environment, that may be necessary. There should also be a cleanup entry added that will reject all other connections other than the ones previously specified. This can be accomplished by adding this entry as shown here, because just like for our IP tables that it rejects all things that are not previously specified, this will reject all connections not specifically identified earlier. So another thing you can do is encrypt connections with SSL. As with everything else we've discussed, when possible, use encryption. Most of the time it is available. It's an easy step to take to add significant security to your network. Nothing should be transmitted in plain text if possible. So Postgres supports using SSL to encrypt and secure client and server communications. In order to achieve an SSL connection, both client and server need to have OpenSSL installed on their system, and Postgres must have been set up to support SSL when installed. Another thing that needs to happen is within the PostgreSQL.conf file, there's a parameter labeled SSL that needs to be set to on. So as I said, a database is not something I was previously familiar with. I'm obviously going to learn more as we continue the course and on to moving into higher level roles outside of what I do currently, which is more of a systems administration, network administration. I don't touch databases so much. We usually use third-party vendors to do that as they're trained specifically in that. But I hope you enjoyed my presentation and you learned something from it. And I look forward to learning more from everyone else's presentations. I'll probably watch much more than I've